Hello. Let's talk a little bit about the physics course. The physics course, the way I have it set up, has been an evolution of over 20 years of material and text and lecture material that I've accumulated for this course. Probably one of the first things that you're going to notice when you start going through my presentation slides, PowerPoint converted to PDF, is that they don't exactly match your textbook. And of course, this should be the textbook that you have, the Survey and Fuel. This textbook, the 10th edition, is what we'll be using. This happens to be 2 semesters worth, so you may have the thin one. If you look at this textbook, if you pop it open and look at about the first 14 chapters in here, those chapters are pretty much the chapters that you will find in every first semester physics textbook. It goes from mechanics, everything in mechanics, introduction, motion in 1 dimension, vectors, 2 dimensions, laws of motion, chapter 4, energy, chapter 5, momentum, chapter 6, chapter 7, rotational motion and the law of gravity, chapter 8, rotational equilibrium and rotational dynamics, chapter 9, solids and fluids, and then we start moving away from mechanics, the typical kinematics that you would find in Newtonian physics, and we move into the heat-related chapters, thermodynamics. So in your textbook, 10, 11, and 12 are all heat-related chapters. And then the last 2 chapters that we're going to look at in part 3 of this book is chapter 13 and 14, vibrations and waves. So all 14 of those chapters are the exact same things that you find in all physics books. Now, in the past 20 years, I have used various textbooks. Okay, the Survey and Fawn was the textbook that I used starting in 2003, various editions, and then we moved to this Wilson, Buffa, and Liu book. And if we pop these open and look at them, you've got the exact same lineup. Okay, so if we take a look at the chapters and how they are set up, chapter 1, an introduction. Okay, chapter 1 should have everything that you need to get started. Chapter 2 then gets into motion in 1 dimension. Chapter 3 moves to vectors, 2 dimensions. Chapter 4, laws of motion. Chapter 5, energy. Chapter 6, momentum and collisions. Chapter 7, rotational motion. Chapter 8, rotational equilibrium. 9, solids and fluids. Starting at chapter 10, again, just like your textbook, we start getting into the science and the physics of heat. So the next 3 chapters focus on heat. Chapter 13, vibrations and waves. We start getting into sound and wave vibration, and then specifically in chapter 14. So all 3 of these books, over 20 years worth of textbooks that I've used to teach this course, all carry through with the same type of information presented in the same order. So what I'm trying to impress upon you is that although some of the examples that you see in my presentation material don't exactly match that in your textbook, the content is the same. Newtonian kinematics, the study of mechanisms, heat, and waves is all the same. So, you can rely on any textbook. I give you lots of information in Canvas that you can look at and try to get other exercises and round out what you know about the subject, and getting familiar with Newtonian physics. The thing to do and that I want to impress upon you is in chapter 1, we're going back through and we are reintroducing things that you should have either learned early on in high school, maybe even junior high school, and should have a pretty good foundation on. Understanding the number line and the two-dimensional number line. Understanding coordinate systems. Okay, the rectangular or the Cartesian coordinate systems. And then moving into the polar. At the end, we get into a little bit, you can see on the bottom there, of trigonometry. We're only going to concentrate on right triangle trigonometry to solve problems like this one in your book. You can see here the airplane problem. You can see what they're forming there. A right triangle. One angle is always 90 degrees. So it helps you build on that because we're going to use that later. By the time we get through chapter 2 and chapter 3, where we're using vectors, which is right triangle trigonometry, and we get into the problems in chapter 5, which are energy, we are going to use that information about energy to help us solve the problems. So by the time we get to 5, when we use energy, or looking at energy, we are looking at problems, and you can see here with the bucket problem, or the guy on the bottom there holding the box. Notice at the top, right triangle. We're looking at forming a free body diagram, forming something that we can look at in terms of drawing a picture, if you will, of what's going on in the problem, and then using the math to help solve it. The thing to remember about this course is every chapter builds on itself. What you learned and what you refreshed in chapter 1, you're going to use in chapter 2, and then you're going to expound upon it in chapter 3. Because everything in chapter 1 are the basics and the fundamentals that you need to build one-dimensional problems. Chapter 2, we look at one-dimensional problems and maybe throw in some two-dimensional problems. And then by the time we get to chapter 3, we're looking at two-dimensional problems where we're looking at the length, the distance, we're looking at the velocity or the speed, and we're looking at the acceleration that's going on in a problem to help us solve a problem. So the thing to do as you start going through this and maybe get a little frustrated, if you get frustrated in chapter 3, go back to chapter 2 and make sure you understand all of those formulas. Make sure that you rely on going back to the cover, inside cover of the book, and that you understand these things that are presented to you. In some of my older books, I used to put lots of formulas in the on the inside cover, and I would mark them up because that's your quick reference. If you're not making notes to yourself, and here, notice here at the top of this page, this is one of the oldest books. Notice at the top of the page, by the time you get to chapter 2 and chapter 3, you're going to be relying on those formulas all day long for weeks, okay? And then you're going to use those formulas again later in the semester. So if you don't have a notebook where you are building your reference information as you go along of these formulas, I suggest you do it now. Get you a notebook, mark it chapter by chapter, put the information that you need with the formula to help you understand it. As you encounter them, write the page number in your notebook so you know where to find it very easily if you need to go back and look at an explanation of that formula that you're looking at. Okay? So the thing to remember, everything in this course is not higher order math. Higher order math moves solidly into all uses of trigonometry and calculus. We will not be getting into any of that. All of this math is math that you would have learned in junior high, or high school.